Welcome to solverfy.
This question wants us to find the electric field and the magnetic field 2.5 meters away from a light source. And that light source has a power of 18 watts. So we already know the distance, 2.5 meters, and its power, which is 18 watts. Well, we know the equation for intensity of a light source, which is capital I, 1/2 epsilon naught, the permittivity of free space, which is a constant value, times the speed of light c, times the electric field squared. So let's solve for the electric field. So to get the 1/2 to the other side, you multiply both sides by 2. To get rid of E naught and C, you divide both sides by E naught and C. And to get rid of the square value, you take the square root of both sides. So for the electric field, we should get 2 times I, the intensity, divided by epsilon naught times the speed of light, and all of this to the square root. So we have epsilon naught. We know the speed of light. Well, the only thing that's missing is intensity. And we know intensity has units of watts divided by meters squared. But we have watts. We have meters, so all we have to do is double meters. So for watts, we have 18 watts divided by meter, so we have 2.5 meters squared. And so for intensity, we get 2.88 watts per meter squared. So now we can plug in our numbers to find the electric field. So we have 2 times intensity of light, which we just found, 2.88. Divided by epsilon naught is 8.85 times 10 to the minus 12 times the speed of light, which is 3 times 10 to the 8th. And of course, all of this under a square root. And so for the electric field, we get 46.5 volts per meter. Now that we have the electric field, we can easily find the magnetic field because we know the speed of light c is equal to the electric field divided by magnetic field. So now we solve for the magnetic field, and we get the electric field divided by speed of light. We just found the electric field, 46.5 divided by 3 times 10 to the 8th. So for the magnetic field, we get 1.55 times 10 to the minus 7 teslas.